Hey,
Good evening.
good evening. How are you doing? Sorry
Doing
about
well.
that invite. That didn't. I tried to use the scheduler and I did something wrong because the scheduler didn't work.
No
Um,
problem.
so we'll make tonight's uh, presentation pretty fast. I added some stuff to our Canvas website. I wanted to show you where that was at. I kind of wanted to go over the schedule, and we will get a recording of that. And instead of going into balancing, tonight we're going to talk a little bit about resurfacing. So it's good to hear your voice. This is a weird deal. Like with spring break being in the middle, it kind of threw us off, and man, it's weird. Sometimes one day flows to the next when you're not going into the office every day. As far as going into stuff, I've been back and forth with the administration of Sierra College. We're still working on the re-entry time, and I'm trying to get 3 work days or um, 24 hours total of lab makeup time for those who want. So that's currently what I'm trying to get going. I have another meeting with them scheduled for tomorrow, so we'll see what happens. Um,
Alrighty.
right on. So I'm at our Canvas page, and what is new is I've added a discussion here on building an old school six engine engine power. So there's two pretty decent engine shows. There's Engine Masters. However, most of those episodes you have to have Motor Trend on demand for. Engine Power is
Mm-hmm.
okay. There's a little bit more sales pitchy stuff going on there, but I cherry picked this one because it's a nice view of the machine shop that the hosts used to work at, and they do some good assembly and so some good machine work. So I put together a little um, discussion related to this episode. There's definitely some stuff that some nuggets of information we can pick out there. Um, so that is new on our Canvas site. Also, if we go to the modules, let's see, here it is. I've added some information there. Again, links to that discussion. I also have bearing catalogs for regular automotive and for performance. And we have some other things related to piston rings. And we'll do another series of discussions on their episodes that are related to building an in-house power mouse, which is a small block Chevy is often called a mouse motor because when the big block Chevy came out, they decided to call that the rat motor, and so small block became
Mm.
a mouse. Anyways, again, it goes through pretty good assembly, so it's a good video to look at for engine reassembly, and it's fun to see what they're tuning on their dyno. Um, in an ideal world, we would have our machine shop lab and then their engine dyno and chassis dyno and stuff. So
Mm-hmm.
those are the things that I added to our site. Um, and what we are going to do is basically, if I punch up the calendar, we will have class each week, and I'll go ahead and I'll change this date to say resurfacing, and I'll push stuff back. But basically, we'll have class tonight, the week after that, oops, and we'll finish up in the beginning of May. I have your test that I've broken up into different sections, which I basically took what was normally the midterm and the final, and I have it available on Canvas for you. But all that will give you your grade in the class, and then you can choose to come in and do your makeup lab work, or at least turn in your lab packet and get credit for the class. I also told the
Okay.
administration that if whatever happens and they're not able to let us back into the shop, I've been working with them to purchase a lot of the better machine equipment from Sierra College. So we'll get that stuff here hopefully pretty soon. And I'll transfer it to AR, and you guys can always come there and finish up your build. So anyways,
Awesome.
that's what's new. I have this schedule, and I have that activity, and I'm not sure if I linked that or not. Let me look at one more thing related to our course. I also loaded a series of videos on engine balancing to YouTube, but I don't know if I have linked those to the Canvas page. Let me go to announcements and see if I did that or not. No. Okay, so I will get that going as well, because on YouTube, if we go to it, I do have 3 videos I added, balancing 1, 2, and I thought there was a third one on here. Anyways, I have some balancing videos that kind of go through the process. I'll have to find where that's at. But I'll have those videos to share with you guys as well. So, all right. So with that, what I'm going to do is I'm going to minimize this, and I'm going to open up this presentation here on resurfacing, and we'll go through this real quick. Surfacing is one where I don't have like a real detailed video on it. I have some quick videos on it. They resurfaced the engine block on that engine power show, but all the stuff is pretty quick. So I put this presentation together to get into some nitty-gritty related to using the surfacer. I know that you guys have used that surfacer when you did your cylinder heads, but I just wanted to cover some bases with it as well. So with that, let's jump into this thing. All right. So today's engine blocks. We're running a lot of different metals. We're using thin wall castings if we are using cast iron, or using aluminum, or aluminum and cast iron. Those have different expansion rates. So, it's a tough job that the cylinder head has to do to get these things to get the head of the block to seal up and act as one unit. With that, the new standard in gasket design is what they call these MLS gaskets, or multi-layered steel gaskets, and we'll get into some of the details of those. Obviously, we know that the gasket surface can't have a lot of warpage to it, and the normal rule is that you can withstand up to about 1,000ths per cylinder bore, but you don't want more than 1.5 thousandths in any one spot. And that means at max, if you had a gentle slope going across the bore for this guy, I could have 4 thousandths, but again, I wouldn't want too much in any one spot. In addition, the surface needs to be smooth enough to provide some movement related to thermal expansion, but it also has to provide enough bite for gasket retention. So it's got a tough job there. If it's too rough, of course, the head gasket's going to fail, and they like to fail between cylinders or between coolant passages, sometimes between oil passages, and can cause us all kinds of grief. So let's keep going here. Clear those out. All right. So our surface finish on our cylinder blocks and heads, and oftentimes you'll hear a gasket manufacturer speaking about RA, or roughness average. And we actually talked about that a little bit when we were talking about cylinder surface finishes. And so in this slide, we have a 30 RA, or roughness average, and a 60 roughness average. And of course, the proper RA is going to give you that right surface that gives you the right compromise between bite and smoothness, right? Now, we looked at this a couple weeks ago as well. This is a profilometer. This is a nice, the top line Mitutoyo model. That guy right there is around $7,000 to $8,000. It has a little stylus that moves across the surface, that moves back and forth across the surface, that feels what the surface value is and gives you this readout right here to let you know what your roughness average is. And in high-end shops, those are getting more and more popular. They sell a low-end model of this that's somewhere around $2,000 to $3,000. Yeah, that's the screaming deal, right? Okay, so we know that the engine block should be fixed in our surface machine, and that most surface machines are going to try to index that block off the main bearings, and we want to try to make everything nice and level and parallel as much as we can. And if the machine is set up right and the main bearings are straight, this guy should make the deck surface parallel to the main surface. So most of the time, you're going to want to take care of the mains first and make sure that those are straight before you would use the boring bar, or in this case, before you would use the resurfacer, because we are indexing the deck surface then off of the mains. Like it says on here, if there's any surfaces that aren't perfectly flat, we're going to have failure. And oftentimes where I see people have repeated head gasket failures is just, you know, improper assembly. They don't get stuff surfaced like it should be, and they end up with surfaces that aren't flat, or they don't follow the torque sequences, or they don't replace their fasteners like they should, or they don't do the right procedure, and then they wonder why it fails again. So it's one of those things where even in, you know, production engines today, even if you haven't increased the power substantially, everything is pushed pretty far to the edge of its normal capacity. And so even in a stock application, following those procedures is really critical. If we were throwing a block on the resurfacer, one of the things we need to remember to do is to take the dowel pins out. And it seems like that would be common sense, but I've had lots of people forget to pull these dowel pins, and then it chunks into the machine and creates all kinds of havoc. Now, ones like this one come out pretty easily with pliers, but the smaller ones, you often have to use a dowel pin removal tool to get those things out of there, and they can be a real pain in the butt. Now, if it's an open block, meaning that these holes are not blind, like this, you can look at this hole here, and that goes down into the water jacket passage, right? So imagine it didn't have this type of a dowel, but it had one of the small dowels that was that was pressed in here, right? And if I couldn't get it out, this tool kept slipping off of there, I could just use a punch and hammer it through and then pick it out with a magnet out of one of the water jacket passages. So that's an option that I see people fight with this tool and forget that, hey, if it's an open surface, I can hammer it through there. Obviously, you want to replace these pins, these dowels, whenever possible. Even with this style up here, oftentimes you'll end up knurling them up pretty bad, pulling them out even with some pliers, and you'll want to end up replacing those. All right, right along. So then your next step is to get that cylinder head or that engine block all squared up and level to the cutter as much as you can. And if it's not going to be level, you need to make sure that, well, it's not level because it's not square to the mains. Oops. it's not square to the mains, or that you haven't just set up the machining correctly. So I have a couple of images here to bring out some different issues, and that, for instance, a lot of the newer machines, like this one in the picture, has a nice attachment for a dial indicator there, so you can make sure that this head is set up pretty level to the machine. And likewise, it would work the same way if it was a block on the machine. So it's got the built-in dial indicator. At Sierra College, we often use machinist levels. Of course, those work a heck of a lot better if the surfacer itself is level, but you can compensate for if the surfacer is off by a little bit. You just want to make sure that the head surface here matches this surface there, right? Now, the nice thing about these surfacers that index off the mains is that it allows you to rotate the engine block from side to side and cut both deck surfaces the same height, so that this block deck height is the same on both sides. And that's critical, right? Because if this side was cut lower than the other side, I would have higher compression on this side of the engine than I would have on that side. And so if you use the machine correctly, you should end up with the same deck height on both sides. Here we have a caliper measuring that deck height. There's a couple other tools that you could use. One of the things you could do is fab up your pistons and do a test build. So if your piston was in the cylinder bore, you could measure the height of that piston on both sides to see if there's a difference between one side to the other side. Not sure if I included a picture of that, but that would be one way, or a long set of calipers, and they do make some specialty tools to check that. And it is something worth looking at if you have a V-type engine and you've had it machined somewhere. You know, was the machinist paying attention, and did they make both sides of the block square? So something to look at. All right, different styles of machines. At Sierra College, we have both wet grinder styles, and we also have cutters. The nice thing about a grinding style machine is they work well for aluminum or cast iron. They do tend to make a little bit more of a mess, but in years past, if you were going to handle aluminum, that's what you had to use. Slower material removal. And of course, as I'm cutting this surface off, I experience stone wear, and these stones are not cheap. Those stones can be anywhere from $500 to maybe $1,000. So they're definitely not cheap. And then as they wear down, they don't wear too much with aluminum, but for cast iron, if I was doing cast iron, for every, let's say I moved the machine down 2 thousandths, it would really only probably take 1 thousandths off of that head or that block, because I have the same amount of stone wear occurring, right? So stone material is sloughing off the cutting stone as I am working my heads. And then of course, anytime I dress the stone, I'm taking material away. If I'm doing just a bunch of aluminum, I do need to dress the stone to keep that stone clean periodically. If you do a mix of aluminum and cast iron, usually doing a cast iron block or head will dress up the stone good enough for you that in between aluminums, you end up not having to dress the stone so often. But they don't take as much material away. They tend to make a bigger mess, and you have to pay attention to what you're actually removing, because you are going to have some stone wear. So if you're looking at your feed and your feed says, you know, I've taken off, I don't know, let's say 10 thousandths, well, you probably haven't really taken off 10 thousandths. And so you'd want to set up a dial indicator or some type of depth gauge on a spot in your combustion chamber to check your work there, to really see what you were doing if you were doing a high-end build. All right. So our other style of machines would be the dry cutting machine, right? And of course, we have our old Storm Vulcan in the shop. And of course, the older machines, the cutting bits on them were really only set up to deal with cast iron. The speed that the machine was set to, its feed rate, and these bits were really set up to cut cast iron and could not handle aluminum. However, the new machines have different carbide cutters on them. They can operate at variable speeds, both for the speed of the cutting head and the speed that it sweeps across the block. And so because of that, these machines, a lot of them are computer controlled, and they're becoming kind of the industry standard. They give you more flexibility as far as setting things up, and can cut faster. They can definitely cut faster than a grinding a wet machine, and they make less mess, but they are pretty darn expensive. So anyways, that's kind of the new standard. Our old dry cutting machine works great for cast iron, wouldn't work good for aluminum. So Phil, like your Subaru engine, you would want, if you needed to do surface work on that, we would have to use the other machine.
Mm-hmm.
Yep. All right. So now we're gonna finish this thing up with a little bit of gasket tech. And that is the MLS gaskets are becoming more and more of the industry standard because you have multiple layers here that can slide on each other. And when you have different expansion rates between a cast iron block and an aluminum head, or even an aluminum block and aluminum head, you have two different masses there. So because they have different amounts of metal, they're still going to expand and contract at different rates. These gaskets really do a great job at being able to adapt to that. Now, the outer layer you can see has this kind of surface coating on there. And because of that, you don't want to use any copper spray gaskets or anything. And I make a point to share this because I've seen a lot of guys still using this on these type of gaskets that don't need that. So, you know, I'm a big proponent of, hey, if you get something, whether it's I don't know, any parts you get, and if they come in a box with a little thing of instructions, read the instructions, right? And they'll give you some good tips on how to set that thing up. And all the time in my career as a mechanic, I would get, you know, something would happen and they go, well, how'd you know how to do that? And it'd be like, well, I read the instructions in the box. Okay. So, yeah, maybe you do that when people aren't looking, so they don't give you a hard time, but you can learn a lot by reading the darn instructions. So they'll say, hey, don't use these sealers on there. And I see guys do this type of stuff all the time and create themselves all kinds of problems. So what this is designed to do, this surface coating on the gasket, once the engine gets up to temperature, this basically melts in to the surface of your head or of your block, right? And so that sticks to that surface, but it can slide on the inner surface. And again, on the bottom layer, it sticks to that surface and can slide on the inner surface. So my important note here is that, you know, this is a non-reusable gasket, right? Well, what that means is that if you haven't started up the engine, let's say you torqued your head down, and for whatever reason you got to take it apart, you could torque your head down, you could take it apart, then you could put it back together, torque it down again. As long as you didn't run the engine and get it up to operating temperature, you should be okay doing that. But once you have ran the engine, now you're beyond that point of no return, and that if you take the engine apart, this thing's going to peel off that seal coating, and that gasket's not really going to be reusable. If you do get to use it again, it's not going to last that long like it should. So couple of things. I've seen both of those mistakes happen from multiple people, and I've had students trying to reuse these gaskets. And like I said, it might work for a while, but it's not really made to work permanently like that. Again, the surface finish is really important. What are we talking about? Well, typically these guys want a much smoother surface finish. So what we're saying is pretty much about half of what you could get away with a conventional composite, like a good quality Permatorque composite gasket. Um, so what does that mean? 70 or lower, and some might be 30 or 40, but 70 or lower gets you in the right roughness average ballpark. So this one's just barely in the ballpark. This one's definitely, this is the smoothness here that we would want for our MLS gaskets. So they want a smoother surface. They do tend to be able to withstand a little bit more warpage though. Like if the surface isn't quite as flat, it seems like you can get away with that as long as the surface is nice and smooth. So this tends to be one where if you're doing a head gasket job in the field and you can't you can't take it to the machine shop, it's close, but it's not perfect. Maybe you're right on the edge where you got that 1.5 thousandths of surface imperfection, a little bit of a dip in the surface or something. If you can go over this with some fine sandpaper with the deck surface sprayed down with some WD-40, so you're kind of doing a wet sand and can get a real smooth surface, this type of gasket will work good in that type of situation. Again, proper torque sequence, all that other stuff comes into play, but they tend to be a little bit more forgiving than a solid gasket because it has those multiple layers. All right. Thickness. You can get these in all kinds of thicknesses, and they seal pretty well. In fact, they're generally available in a thicker, in a wider thickness range than what you had available to you with conventional gaskets. So here we have 27 to 140. That's a figure from Cometic gaskets. Others are real similar. That being said, you could go to something thicker and take yourself down a notch on a compression for your compression ratio. But if you're having to do big swings, you probably need to make other changes, right? Like maybe put in a dish piston or something like that. So pretty good range on these. And other notes related to that would be if you're changing the head gasket thickness, push rod length becomes a big deal. Of course, if it's a V-type engine, right, is the intake manifold going to line up properly as it sits down in that valley? So those are things to think about. Lastly, you can't stress enough that, hey, good quality fasteners is a big deal, right? The combustion process is trying to blow the cylinder head right off the deck surface of the block. So with that, either good new standard fasteners and read your instructions because it might be a dry torque on these fasteners. If they're going through an open deck surface where they're going into the water jacket passages, they might be requiring that you put some type of sealer on the threads, right? It's really popular, like in this picture here, for people to want to put in thread studs and stud the top surface of their block. And I put this picture up because there's a couple of tips on that one that I wanted to share with you as well. You can see that you have a more standard stud. That's a nice ARP right there, so it's good quality metal, but it's fully threaded. And then you have this one with the kink down here. And what is important, because sometimes it leads to problems on assembly, is normally, like if you put this cylinder head bolt here in that block, the threads wouldn't go all the way to the base or the end of the bolt here wouldn't go all the way to the base of the threaded hole. It wouldn't bottom out.
Mm.
But a lot of guys will put this one in, the one in the middle here, they'll put this guy in and they'll tighten him down to where he bottoms out against the base of the hole. And sometimes what that can do is the way it catches the thread and the way it puts strain on it is it can just make this thing want to lean to the side a little bit. And then you go to slide your cylinder head on and all of a sudden these guys aren't lining up. You're having problems dropping it on. So again, if you read the installation instructions, you know, from a decent, you know, fastener manufacturer, what they'll usually tell you is that this style right here, they don't want you to fully seat those super tight because that could throw them off. They're going to have you lightly seated or drive it down and then back it off one turn or a half a turn. This style here where it's got the machine shoulder and it's not threaded to the end, this style here, you do fully seat those studs. And because they're cut out, they'll maintain their alignment, they'll maintain their straightness when they're fully seated. So a couple different just tips on assembly there that, you know, can throw you off. And again, I've seen it where people go to slide the head on, and of course, you know, if you have some thick heads there, like you can see how long those studs are. So if you were just off at the bottom, if your angle was just off by half a degree, right, that would end up moving this stud to the side pretty considerably, and now things don't line up anymore. All right, speaking about things not lining up, if you ever have an issue like that, like the other day I was trying to put some exhaust manifolds on an engine, so I'm drawing an exhaust manifold here, and stuff's not lining up, you got to stop and ask yourself, why aren't things lining up? And a lot of times you might pull something apart and it came apart just fine, but when you relieve the tension, that component was warped and now you're putting it back on and it's warped. So check for straightness, not only on cylinder heads and deck surfaces, but things like your intake manifold, your exhaust manifold, especially because those like to warp and then parts won't go together correctly for you. So just keep in mind that, you know, having stuff level, having stuff straight is the key to proper assembly there. So with that, we finished up our gasket tips and tricks. And Phil, do you have any questions or concerns, or Brian, do you guys have any questions?
I don't know.
No.
All right. Well,
pretty straightforward.
Yeah, it's a pretty, you know, it's a pretty straightforward deal. What I find is just a lot of folks don't take the time to make sure that they have quality fasteners or that stuff is straight or things like that. Speaking of fasteners, I don't know if I've done my thread wedge analogy with you guys, but I think I will share that with you. Let's see if I can make, let's see, give me a second here, and I'm going to, let's see, I want to whiteboard, that, and I want to make video. Let's see. Optimize screen for sharing video clip. All right. All right. So now you can see me a little bit bigger here. I'll do my, actually, I know it. I'm losing it, guys. I can just use my document camera. I got too much technology here. It's throwing me off. Document camera. There we go. Okay. All right, so I just have a piece of paper here, and one of the things I like to do with this paper is have it simulate a wedge, right? Like if you use a wedge to split some wood, I'll try to shape this paper into a wedge, but a wedge you might use to hammer it into a piece of wood and split something apart would be shaped like that, right? Well, essentially that's how our threads work, because if I take this wedge here and I draw a line on one side of it, and I then take the time to roll that up and make a screw thread out of it, you can see what I've formed is my threads, right? So if you're ever using a fastener and the threads are a little messed up on the fastener, keep in mind if you were to take that thread apart and actually look at the wedge, it would be like you've ripped chunks out of this thing, and obviously it's not going to give you the same amount of clamping force that you had before. So I always like to do that analogy because, again, it shows you just how important fasteners are in your engine. Well, on anything really for that matter. All right, so I got one last little thing to finish our class on. We're going to see
the main caps need to be removed.
We're going to see how this little video here plays. I've been bootlegging some of my CDX videos, and we'll see how this plays through our system. What I found is the frame rate ends up just a little bit slower than it normally would be, but it's not too bad when I tested this earlier. So we'll try this out. What they're going to do is they're going to take every machining operation you would do on an engine block and condense it down into a 3-minute and 4-second video. So we'll see what we can pick apart.
First, so that a small amount can be ground off the bottoms of the seats of the caps. Then the caps are put back on the block and tightened and torqued to spec. Now the opening is no longer circular. It's a slight oval. The size is checked with a dial bore gauge, and the honing stones are inserted and expanded until the proper drag is felt. The honing drill is lined up with the stones, and once the oil starts to flow through the tube above the block, the stones are passed in and out while the drill is running, so that metal is removed and the oval shape begins to return to a perfect circle. As the stones take off metal, the block and caps begin to heat up, and the machinist checks the size with a gauge and takes a break to let the block sit and cool so the metal will return to its true size. After a few minutes,
I can't speak for Phil, Mr. French, but all I'm seeing is you.
Oh, well, good to know. Thank you.
Which, hey, you know, the beard looks good. But,
oh yes, yes. It's been you know, with staying at home, trying to keep my wife happy is utmost priority, right? So.
Yeah. I got the audio of the video, but
you got the okay.
nothing,
Okay,
yeah.
I've done something wrong here. Hang on. I want to share my screen. Let me ask you this. Right before, could you see the document camera?
I could not.
Oh crap. Okay. Well, then that whole thing went. All right. Hang on a second here.
Your explanation was good, but I couldn't see it now.
Okay. All right.
It's like I can see you from shoulder level up.
Yeah.
Yeah.
Okay. Hang on a sec here. Why is that doing that? Oh. No. Okay. I lost. Oh. Let's see. Ask. Huh. Okay, there we go. I got my controls back. Share. Okay. Let's do this. We're going to share my screen. Now, can you see my computer screen?
Yes.
Okay. Now we'll do this real quick, just because I feel, here was my thread
There we go.
wrench.
Okay. Yeah.
that didn't work out. So you can see I ripped it up there, but if I roll this sucker back up, you can see where it starts to form some threads. Of course, now they're going to look a little bit uglier, but here we go.
Yeah.
Right? So you get the idea. So threads actually wedge parts together, and that's what gives you the clamping force. All right.
Okay.
So we got that. So now I will turn it back to the computer. So you should see my computer screen, correct?
Yep.
And we'll see if we can get, it back on the video.
The main caps need to be removed first. So
There we go.
Yeah, they're starting with the line honing operation. So we'll get to that part. All right, here we go. And like I said, the whole thing is only 3 minutes long, so they rip through it pretty fast.
caps are put back on the block and tightened and torqued to spec. Now the opening is no longer circular. It's a slight oval. The size is checked with a dial bore gauge, and the honing stones are inserted and expanded until the proper drag is felt. The honing drill is lined up with the stones, and once the oil starts to flow through the tube above the block, the stones are passed in and out while the drill is running, so that metal is removed and the oval shape begins to return to a perfect circle. As the stones take off metal, the block and caps begin to heat up, and the machinist checks the size with a gauge and takes a break to let the block sit and cool so the metal will return to its true size. After a few minutes of cooling, the stones are run again and progress is checked with a gauge. Then the block is lifted and turned around so that the hone can be finalized to the perfect size from the other side. This is the first process for the block because the next two machining procedures depend on a perfectly straight line through the main bearing bore for proper mounting to the machine.
So I guess I'll pause it right there. You know, one thing about this video is that you can tell that the producers didn't really know about machine work, so their script is a little bit generic. And every machinist has a little bit of style to what they do, right? So this guy, for whatever reason, liked to spin the block around. I don't know if you necessarily need to do that, but we do know that when you're line honing, it always cuts more from the end that's closest to the drill, right? So
Right.
if you know, he was having a hard time removing material from this main right here, which it should cut the slowest because it's the widest, it's the thrust bearing on this small block Chevy here. Normally I would have put that thing on this side to make sure it cuts at a decent rate. So why would you flip it? Well, this character might just flip it because that's his style of how he likes to do it. Ultimately, if he ends up with the right housing bore size, it doesn't really matter, I guess. Normally you would flip it if you didn't have bores that were cutting how you wanted them to. You wanted to more aggressively cut one than the other. Maybe when you were cutting the caps, you cut more material. Something like that. That would encourage you to flip it around to try to get things even when you were done. All right, so I do like how they go from this and they say, hey, now that we got the main bearings in alignment, now we're going to resurface it. And of course, he gets the easiest dowel pins to pull out of there. You know, usually only like 3 times out of 10 times will you be able to pull it out with some snips like that. You usually have to use the dowel pin removal tool or hammer it through or something else. So with that, I'll turn on the announcer again and we'll see what they have to say.
For proper mounting to the machine. Next, the alignment dowels for the heads are removed, and the block deck is leveled. When the deck is perfectly level, the cutting machine is started and runs by itself at a set pace, shaving the surface to make the deck perfectly flat so that the new head gaskets will have no problems sealing out water, air, or oil leaks. When one deck is done, the block is rotated and the machine is set up again. Both decks must be cut the same amount or there will be a difference in the compression ratio from one side of the motor to the other side, and the amount removed in this case was so tiny that the factory number stamping of the block ID was even still visible. Using the same mounting point through the main bearing bore, the block deck is now leveled in the boring machine. The machine needs to be set in the approximate center line of the first cylinder bore. Then the machinist tells the machine what type of engine this is and presses go. The machine takes care of the rest for the first half of the block. This particular machine centers itself in the bore, and the cutting tool for the proper overbore size, which was already set up in the spindle, goes to work once it starts to spin. The boring machine knows how far to go down in the bore for each engine type that is programmed into it. When done, it retracts the spindle and automatically moves to the next bore and centers itself once again. It goes.
So that's a pretty darn neat boring bar, right? That's a newer version of the machine we have that has computer controls on it. That one's probably from the 90s. You still had to either program the start and stop so it knew how long the bores were. You either had to program that in manually, or some of these machines in this era had like program cards you could load in. But that makes it pretty nice. And it can go from one bore to the next. One of the boring bars that we have in the shop is supposed to be able to go from one bore to the next. I have not been able to get it to do it correctly yet, though, because it's still a little bit older than this machine. So it's almost like electromechanical. You have to manually put mechanical stops in there. But once you do that, it's supposed to be able to be semi-automated and go from one to the next. The surfacer that they used is the exact same surfacer that we have, that Storm Vulcan. The surface finish or roughness average that this provides you, I do not believe is smooth enough for MLS gaskets. It's just a little bit on the edge. So a good composite gasket would be a better choice for a block or a head that's been surfaced with this machine. And it comes down to the type of teeth that are on it and how quickly it moves across the surface of the block. All right, we'll get that boring bar set back up.
Machinist tells the machine what type of engine this is and presses go. The machine takes care of the rest for the first half of the block. This particular machine centers itself in the bore, and the cutting tool for the proper overbore size, which was already set up in the spindle, goes to work once it starts to spin. The boring machine knows how far to go down in the bore for each engine type that is programmed into it. When one bore is done, it retracts the spindle and automatically moves to the next bore and centers itself once again. It goes through and cuts all 4 of the bores to size for this side of the block. The block is then lifted out and flipped to the other side to get finished. A piston bore that is still the original diameter as when it left the factory is said to be standard size. Pistons are manufactured for oversized bores in increments of 10, 20, 30, 40, and 60 thousandths of an inch, or in increments of 0.25 or 1/4 of a millimeter to 1.5 millimeters. The boring machine will cut the cylinder wall to fractionally less than whatever bore you will need. The honing machine will later expand it to the exact specification.
All right. So that was pretty decent there, right? We got to see that machine in operation. The newest machines, what they'll tend to be able to do is not only bore all the cylinders, but a lot of the new machines are almost like a CNC station. So that same machine could not only bore all the cylinders, but it could resurface the deck surface all in one deal. And you could program in the blueprints, and in theory, it could center the bores to exactly the blueprint specification. There's a machine shop in town off of Fair Oaks. I'm trying to think of what it's called. I think it's called Motor Machine. Anyways, they have one of those machines, and what they have told me is that oftentimes if you're dealing with older American iron from the 70s, 80s, 60s. There's enough casting shift there that they can't use that machine to bore them perfectly in the center. They have to center off the bores that are there. Otherwise, they'll end up boring through a cylinder wall, or the cylinder walls just get too thin because there's been that much shift. So, anyways, pretty interesting stuff. A lot of the new machinery is very automated and works well in a big production type shop. So that's kind of the new standard. So what I will do for us, if I get this back in the right mode, is, no, I don't want that canvas. I want this canvas, and I closed it. And it's a 27-step process for me to log it back in. What I will do, guys, is I will get our canvas set up, because I have those balancing videos that I've loaded on there. I'll make sure that I get links to those on there. So I got the balancing to put on. I'll load on tonight's presentation, not just the video link, but I'll also load on the actual PowerPoint here. I'll get that loaded up on Canvas as well. I'll convert it to an Adobe document for you, and we'll keep plugging away. So next week we'll get into balancing, and then we'll shift gears and go to assembly. I'm going to put a couple more just fun videos for you guys to check out that are pretty good, that will aid to our discussion. And our hope is to get back in the shop and finish things up. And I think what I'll do is I'll push for them to, like I said, give us 3 days of shop time. But no matter what, if you guys, plug along with me and continue on the stuff, I'll also make sure that you guys get your grades out of this class. So at least you get credit for doing something in it. So with that, unless you guys have any questions, I will wrap this thing up and let you guys get back on with your normal lives. I hope you're all healthy and safe and doing well out there and everything else. Do you guys have any questions on anything?
I've got a couple questions.
Okay.
If I want to send you an email, which one would be the best? Would it be
the ARC email works better? Okay. I have so like you can see my computer screen right now.
Yep.
And for whatever reason, like I've tried to put on, here's my Sierra College links, and about half the time it doesn't seem to work. Like it always wants to default to my ARC Outlook. So if you can send me stuff to ARC, it honestly would work better. Or if you email me through the Sierra College Canvas link, that does work pretty good.
Okay.
But the regular Sierra College email is weird. It's just half the time I can't get it to log in right, and then the other half of the time I have people who say they've sent me information, and then I open it up and I didn't get it.
Yeah. And then I don't know if you talked about it. Obviously, I was I don't know, 30 minutes later, whatever, logged in tonight. But if they do open it up this summer for a few hours, given this whole thing now about social distancing and stuff, I can't see all 12 of us being in the shop at one time.
Yeah. And I'm not sure. I'm going to go there to the college campus on the 27th for like a shop inspection, and we're talking. I'm going to be talking to some folks about the equipment and what happens to it and stuff. At that meeting, after that, I'll know more. I think it depends on when can we get in there, and then when I give you guys the dates, I'll have to do like a head count of like how many people want to go in the shop. I think there's going to be some folks that are just going to say, hey, let me come get my crap and I'll see you later, right? And I don't think all 12 of us are going to end up in there.
Do you have a number now? I mean, do you know if anybody's dropped or?
Yeah, so when I look at the activity, so I can see how many minutes or hours or whatever you guys are on there. Of our 12 people in class, really, I only have 8 of you that are plugging into Canvas at all. So I figure at most we would have 8 people come back, and that depends on the dates. I can tell you, I got insight because I have both colleges, right? So at ARC, I mean, they did a whole bunch of different things. I had to move all of our classes to online instruction for summer. We only had a few summer school classes, but so AR is going to be closed down throughout the summer. Initially in the fall, AR said that they were going to start like for the first half of this semester online, and then hopefully get into the shop halfway through the year. But I just had to rework the fall schedule again, because now they're saying that they think we're going to start off like normal in the fall, and then when cold and flu season comes in, they might have to shut down the school again or limit us or something like that. Because when that comes into play, you know, you're not going to be sure who's got the flu and who's got the virus, right? So it just kind of shows you how much stuff changes each day. So we're still not really sure where we're at. April 27th, like I said, I'm going down there, myself and Jennifer, and we're meeting with the administration and doing a shop tour. And so I'll know more after that. But my plan is after that is to try to set up appointments for people that just want to pick up their stuff. Like if you just want to pick up your engine parts and drop off your worksheet, and then I can give you a grade. Or if you want to come back and finish your work, I can figure out what days hopefully that hopefully we'll be able to do that. I'm pushing for 3 full days. I know the administration doesn't want us to spend like a zillion hours down there. They don't want us to be down there for weeks, and they're trying to push for less. I added up our class hours, and basically if you took the 4 hours for each week, you know, and you dropped one off for like the final exam, we missed out on 28 hours of lab time from 6 to 10 p.m. So I'm trying to negotiate them out of 24 hours. So if I can get like 3 good days down there, I think that would give you guys the time to at least get your major machining operations done. And then, you know, as far as your grades, if you complete your tests online and kind of plug into the discussions and we turn in your lab work, I'll make sure that you get a good grade. So I appreciate you working through this deal. The other thing is that, like I said earlier tonight, that my plan is, and I've been in good conversations with Sierra College. In fact, that's part of the reason why I'm going there on the 27th, is I want to let them know like what pieces of equipment I want to purchase for American River College's program. And then after we got in and did our machine work or whatever, my plan is to then move that stuff to AR and set up a machine program there that does a lot of the same things, maybe not to the scale that we did it at Sierra College, where we had a separate class for heads and a separate class for blocks. But that we had a class where students could go through and build their engine and focus on different things. And we have some classes that are listed as special projects that would allow you to come in and kind of get free shop time and stuff and use that stuff. So that's another option as well. And I told Amy, I told the dean of Sierra College, I said, look, if something happens and we can't really get in the shop and get work done in a timely manner because of regulations, at least we need to get our parts out of there. And I told her I would be more than happy to have you guys come to the other school once I get the equipment and stuff moved and finish up your machine work there or your build time. So I'm trying to make it as right as I can for you guys with everything that's happened. All right, so good question. Thank you for asking that, and I'll type something up related to that, and I'll also throw that on the Canvas page as well.
Okay,
right?
and I got an email I'm gonna shoot you just with a couple kind of questions that kind of fall into, you know, my specific type of scenario rather than,
Okay.
you know, the normal guys, but just,
Yeah.
you know, things I want to kind of pick your brain on. So no big deal, but
Sounds good.
yeah,
All right.
I'll fire off
Well,
an email to you.
Yeah, it's good to hear your voices and to know that, you know, you guys are out there, and it's just so weird. It's a weird deal, and I'm just happy to hear that, you know, people are out there and they're safe, and you know, it's kind of fun just to even to be able to talk about engine stuff is kind of fun. So, anyways, with that, we'll end tonight. Thank you so much for being here with me. I apologize for messing up on the Zoom scheduler, but I'm slowly getting better with this technology. So take care, and hopefully we'll catch you next week. Okay.
Okay. Good
All
night.
right.
Have a good week.
All right.
You too.
Okay.
Thank you.
Bye.
See ya.